All right. I want to show just a few more interesting examples before you get started on your IP today. So this is the last of the 4.9a video. So for this number 3, what I'd like you to kind of think about on this one is it's kind of a hybrid between an area under the curve problem and an area between the curve problem. So it says, set up the integral that allows you to find the area in the first quadrant that is bounded above by y equals the square root of x. So we'll just write that. Y equals to the square root of x. And then this equation is y equals to x minus 6. So I would actually outline this into 2 regions of integration. So we'll call them region 1 and region 2. This is region 1. And then that's region 2. Region 1 is just between the x-axis and the square root of x. So when you have an x-axis, so this is going from like x equals 0 to x equals 6. And then region 2 goes from x equals 6 to x equals 9. So when you go from that first region for calculation, we're just going to write that as an integral. So we're going to do the integral from 0 to 6 of the square root of x. Now, the equation for the x-axis is y equals 0. If you wanted to call it square root of x minus 0, that's okay, but that's kind of beyond the point. And then region 2 calculation, this would just get you from 6 to 9. And you would have the square root of x minus a x minus 6. So those are our 2 integrals. And once when we have those mapped out, it becomes, just solving the integrals. Remember, I like, instead of square root of x, I like x to the 1/2 better. So we're going from, take that antiderivative. So we're going to get x to the 3/2. And I like reciprocating that 3/2 to get 2/3. And we're evaluating it from 6 to 0. So when we do that, fortunately, we're okay with 0. That's just going to become 0. And we may want to get a good calculator out for the 6 to the 3/2. Times 2/3. And I'm fine if you put it in decimal. So it would be about 9.79 for that integral. And we want to go to the graph and just check out to see if that's a reasonable estimate. So we can see that whole first row of 6 is almost taken up. We'll call that like maybe 5.5-ish. And then we're looking at something like maybe 4 on the second row and a little bit of change on the top. So 9.79 definitely is very feasible for that. So then we're going to go region 2 and compute that integral. So I got the integral from 6 to 9. So we have x to the, we'll just change it into that fractional exponent. So we got 6 to 9 of x to the 1/2 minus x plus 6 dx. So we get x to the 3/2. So I'm 2/3 minus 1/2 x squared plus 6x. And in the real world, you may want to, be using a calculator for this one. You definitely got your share of nasty numbers for this. So we're just going to, see what this comes out to. So we got the square root of 1/2, or x to the square root of x, minus x plus 6. And our limits of integration are from 6 to 9. So what we would get about when the chalk dust settles, it's about 3.7, give or take. And you would just want to add up those two numbers together. So you would just, for that final result, you get 9.79 plus 3.7. So that would get you about 13.49 for your final answer. Number 4, I kind of like this question because I like you to kind of think hard about the concept of the integral and the limit of integration. This is set up, but do not solve. So what I would do almost immediately is just think about finding that limit of integration. So when we do that, we would get (3x cubed) minus x squared minus 10x equals to negative x squared plus 2x. We really want these to equal to 0, so I'm going to add the x squared to both sides. Subtract the 2x to both sides. So this is maybe a little bit harder in the food chain of solving polynomials that you saw in Algebra 2. So you get 3x cubed minus 12x equals 0. Pull out a 3x, so you're going to get x minus 4. So you get 3x equals 0 and x minus 4 equals 0 for an x equals 4. Oh, this is actually a x squared minus 4 because you're actually in the x cubed land. So you would, this is your good old favorite factoring method, difference of 2 squares. So we get x equals -2 and x equals +2. Then what you want to do, so what's probably going on is you're having a situation where the top and the bottom functions switch. You know, maybe you're getting something like this in this particular problem. And this may be a little bit more difficult than what I'm asking you on the homework. I'd probably give you a graph on the homework assignment today. So then what I would do is I would look at f of -1. And I choose -1 because that's between the 0 and the -2. So that would be 6. And if I plug -1 into g, that would be -3. So your first integral would go from, you know, -2 to 0, and your f would be on top. And I'm fine if you just call this f of x minus g of x. And it's better to be safe than sorry. So maybe on the second integral, I would choose f of +1 and g of +1, and I would plug them into the original functions. So I would get you know, something like -8 when I plug in my 1. And for the g, I would get like -1. So then your g of x would become the top, and your f of x would become the bottom. Make sure that you are including a dx as well. Now notice here, it does not say solve. I think you would be having a lot of fun, you know, solving it, but, you know, what I kind of did here, and the purpose of this type of problem is just getting you really thinking critically about how you're setting things up and incorporating the concept of area between the two curves. So with that being said, good luck on your IP, and feel free to drop by to an office hour. And also make sure that you're enjoying the nicer weather this week too. Have a great day. Bye-bye.